Welcome everyone. So very happy to see you all at another workshop this week. We'll let you get settled in. We have a few people joining yet. And while you're getting settled in, we would love to know where you're joining us from. So go ahead and drop any info you want to share with us into chat. You can tell us where you're joining from, what you teach, or anything else you'd like to share with us today. I am seeing a lot of people who have been at some of our previous workshops, and this is Python week, so we have a lot of people waiting for this week. So welcome, everybody. Hey, Carla, it's good to see you. Hi, Kelly. It's like we have a couple of Indiana teachers right off the bat. Hi, Kim, it's good to see you as well. Hi, Phil. Welcome, everybody. I see so many returning teachers. So thank you for coming back to another CodeHS workshop. We're very excited to have you here with us today. For those of you who may not know me, my name is Lori and I'm a CodeHS PD specialist. And I have been with CodeHS for over 3 years now. And prior to coming to CodeHS, I was in the classroom I was in K-12 education for about 20 years. As a technology director and a computer science teacher. And I use CodeHS in my own classroom. So I love being able to be here with all of you and talk CodeHS and hear about all of the awesome strategies for teaching with CodeHS. Hey, Mark, it's good to see you. Carla is driving. I hope you don't try to interact, Carla, if you're driving that car. I'm glad you could listen in. Welcome, everybody. Welcome to Reshmi. Hope I'm pronouncing names correctly. Whew, I got it. Yes.
It's going to be hard, Lori. It's going to be hard.
Oh, sheesh. You be careful, lady. Yes, I might have known Carla for a while now. So. All right, we have a bunch more people joining us, so let's go ahead and get settled in. If you're just joining us, go ahead and toss an introduction into chat. We'd love to know where you're joining us from and what you're teaching next year. And we'll get started shortly. As we're getting settled in and we're letting a few more people into the room, I'll go ahead and start by telling you a little bit about who is here from the team today. So we also have Gary here from support. Gary is going to be helping us on the back end, tossing a bunch of links into chat. He's going to be helping us answer questions and everything. Gary's very fast. Could not do this without Gary, so thank you for being here. We also have Robin from the PD team here as well, and she's going to be helping us out with questions on the back end also. Hey, Robin. And we have Lindsay joining us too. Lindsay is also on the PD team. We are fully prepared to help you in whatever way you need. We got plenty of team members here today. So thank you to Robin, Lindsay, and Gary for being here. And of course, I would be very remiss if I didn't tell you about our speaker, our guest of honor today. And our speaker today is Rob Kramlich, fabulous computer science teacher from Georgia and a CodeHS teacher trainer. He's got so many amazing things to show us today. So I am going to go ahead and get us started. So Rob, let's go ahead and go to the next slide. So we already started some introductions, so you can keep throwing those in. What I would like you to do today is make sure that if you want to have some chats and discussions, go ahead and toss that into chat. This is a really good opportunity for all of you to interact with each other and really start becoming a part of a larger CS teacher community. So please take advantage of that chat. If you do have questions, we do have a Q&A available. We'd love it if you could add those questions to the Q&A so we don't lose your questions. We want to make sure we answer any questions today. So our first link is on the screen. You can access the slides today at codehs.com/deeper-dive-python-slides, or you can scan that QR code and that will get you to the slides. And even better yet, you're going to want this link that you see on the slide deck. This is the link for the workshop docs, or for the workshop links doc. There we go. Just a lot of words. They're all muddled together. So grab this link, codehs.com/deeper dive python-links. This is going to give you all the links that Rob will be using in the workshop today. If you are not in a good place to grab this link right now, no worries. We will definitely send this information out in a follow-up email once we have the recording ready to go. So you can either scan that QR code or grab that link, or wait for the email to come on out about that. And Gary just tossed those into chat as well. Now, if you are just joining us for the very first time and you've never used CodeHS as an educator before, please go ahead and browse to codehs.com/signup. We would love it if you take a moment to go ahead and create your CodeHS educator account. It's absolutely free, and it only takes a couple of minutes to sign up. If you are signing up for the very first time today, you may not see all of the things teachers would usually see. There's a little verification process we go through. If you are a brand new teacher, go ahead and drop a message into chat to any of us to go ahead and we can get that verification process started for you. All right. Once you have your account created or you have an account and you've signed in, please browse to codehs.com/go/86831. This link will allow you to enroll in the workshop section. Let's leave it on this slide for just a moment. I'm going to let everybody take a moment to go ahead and get enrolled. And I'm also going to take a quick peek on my end just to see how we're doing. If you do have any questions or problems at all with enrolling in the section, go ahead and drop a message into chat and we can help you out with that. Looks like we've got at least 7 people in right now. I'm guessing if I refresh, there's so many people joining. Love it. It looks like you're all getting in, so that's perfect. Love it. All right. I'm going to glance at chat real quick. Laura is joining us from Georgia. You've taught JavaScript and you're switching to Python. I can tell you, I made that switch too. I started with JavaScript and I switched to Python when I was teaching. And honestly, it was an amazing switch for me. I love JavaScript, but I really, really love Python. That is still my favorite language. I think you're going to really like it. I'm glad you're joining us. All right, let's go ahead and go to the next slide. I think I've got one more link. I do. Okay, once you've got that educator account created, or you've signed into CodeHS, now we need you to click this last link. Gary just dropped it into chat. So if you could go ahead and click codehs.com/deeper dive python-attend. Those are getting to be long links. That one is going to let me send you a certificate of attendance after this workshop is over. So you'll definitely want to click that. When I do send those will come from help@codehs.com. So you'll want to watch for any emails to come from that email address. All right. Now I think I have talked enough. So without further ado, I'm going to turn over our workshop to our guest of honor, Rob Kramlich. Rob, take it away.
All right. Hey, everybody. I'm really excited for this workshop. I've been teaching CS for 4 years now in Peachtree City, Georgia. I actually, just a little quick thing about me. My bachelor's is in education, but as soon as I started teaching CS, I fell in love with the subject. I'm going back right now to get my master's in computer science, just so I can kind of get a more technical feel, bring a lot of those industry relevant things into the classroom. What I've got for you today is a lot of really cool stuff. We're pretty much breaking it down into 4 sections today. The first one's a little bit shorter. We're just going to talk about the CodeHS courses in Python, what CodeHS has to offer there. We'll do some comparing and contrasting with AP Computer Science Principles if anybody's going to be teaching AP Computer Science Principles next year. After that, we're going to roll into breaking down an entire Python unit. This is going to be one of the longer sections. I've got a lot of examples. I got a few activities for us to work with and to try out. That way that we can kind of see how I structure a unit using CodeHS, how I build projects, those kinds of things. That's pretty much going to be a lot of activities, a lot of things we can do with that. Hopefully by that time, we'll be about halfway through and we'll take a 5-minute break because this is a 2-hour workshop. After our break, we'll go into a few things I kind of added last minute, but I think are going to be a really good addition to this workshop. That's grading and teaching CS best practices. So there's a lot of tools that CodeHS has that we can use for grading and auto grading and all kinds of things to make your life a lot easier. That's the beauty about being a computer science teacher. Once you learn enough, you can build assignments to grade themselves and you have to do less work, which is awesome. So I'll show you some of those things. And then also over the last 4 years, I've picked up a few different things that really, they're really specific to a project-based computer science classroom that I found really effective in helping my students learn and kind of helping build rapport with my students as well. And then finally, of course, we're going to end it with some fun projects, some fun activities, some things I do in my class. Also, some things that CodeHS has added recently in the last year that I've actually been able to take advantage of and use in my classroom that I think you guys will also enjoy. So without further ado, let's go ahead and dive right into this. So there are 2 main courses that work with Python that most teachers tend to use from CodeHS. The first one is going to be the Intro to Computer Science in Python 3. Now, this course, it's 125 contact hours for my school system. That's usually about a semester and a half, so 3/4 of the year. But there's also a lot of supplementary stuff you can add on to this. Now, I've got a couple of links here. We can actually take a quick look at the course overview, which is pretty straightforward. We're starting with Tracy the Turtle, which I believe if you were in the workshop yesterday, they went into a little bit of detail on Tracy the Turtle, but then it builds on there, going with basic console interaction, conditionals, looping, functions, strings, data structures, and then extending data structures. And so usually when I've taught this course, we usually get through about strings and creating and altering data structures by the end of the first semester. And then second semester, we're going into 2-dimensional data structures. We're working with more complex stuff. And CodeHS even has, if you have a really advanced class, CodeHS even has supplementary material to work on object-oriented Python, which is something you can always throw in there as well. Now, there's also the AP Computer Science Principles course in Python. And in just a little bit, we're gonna put out a little survey via Zoom, just so I can get an idea of what you guys are going to be teaching. If we have a lot of teachers in here who are going to be teaching AP Computer Science Principles, I can kind of tailor some of my material and kind of focus on a few of those things. It's perfect. Yeah, let's put it out right now. That way I kind of get an idea. But these 2 courses are actually very similar to one another. Oh, that's the wrong one. There we go. They don't look similar if you just look at the overview, but the actual content inside is very similar. Again, we have an intro to programming, except this time they use Carol and Tracy. Very, very similar in the first half. Tracy goes into more depth. Carol kind of stays a little bit more surface level. But when you're programming with Python, your control structures, that is essentially these first 3 lessons, these first 3 units here. Same material for the most part. We have functions and parameters. They have some stuff that's specific to AP Computer Science Principles, like practice performance tasks. There's also embedded, and we'll talk about this a little bit later. If we have people teaching, looks like we do. We have about half of you guys teaching CSP, so we'll make sure to hit some of those notes. But there's a few pseudocode practices built into here as well, which are extremely helpful if you're teaching AP Computer Science Principles, because they do have that pseudocode test. The programming actually ends with basic data structures. And this is one thing I actually would like, if you're teaching CSP and you're going to be doing this course, there's something I'd love for you to add in there, because there's a bit of a gap from functions and parameters to basic data structures. The assumption is made that students understand indexing. But if you look back over at the Python 3 course, you have functions and exceptions and then your data structures, but you have a string unit in between. Now, the reason there's no string unit in between these 2 is because technically College Board standards, they have it set up to where you're not really working and indexing and building substrings and those kinds of things. That's not actually part of the standards. In pseudocode, it's all just done with a few methods, the concat method, the substring method, all of that stuff. So there's a bit of an assumption made with some of the lessons here in the basic data structures unit that assumes they already understand indexing. So my suggestion is, if you do plan on doing the AP Computer Science Principles in Python course with CodeHS, to actually insert this strings unit from the intro to computer science in Python. That's actually going to be very helpful to your students. Like I said, some of the stuff that's when you start working with the first unit, which is we're talking with tuples and working with tuples, it assumes students already understand the basic of indexing, which they actually get a lot from in strings. It also gives you a lot more to work with, especially if you're building projects. Students learn how to manipulate strings. Is it going to show up on the multiple choice of the AP exam? No, it's not. Can they use it for the performance task? Yes, they can. So it's definitely a great idea to include that into your AP Computer Science Principles course, if that's what you're going to be teaching. And it looks like, looking at the poll now, yeah, we got roughly half are going to be teaching AP CSA or AP CSP, which is great. And hopefully a few are also teaching AP CSA as well. That's a fun course to teach.
I wondered why that wasn't in there.
Yes,
and that's awesome. Thank you.
It's a big gap. Yeah, if you're teaching it for the first time, there's somebody that one of my teachers in the county, she was teaching it for the first time, and she said we went straight into, I'll pull it back up for anybody. They go straight from functions and parameters, and you go into basic data structures. And because the basic data structures right here, creating and altering data structures, is pretty much the same unit. This unit makes the assumption that they've already had strings and they've already taught, because strings has all the basics of indexing and all that built into it, and slicing. And you don't have that in this course. And the reason being is because strings are not a standard in CSP. But it was just a slight, because it's hard. You can't not code HS for that, because it's not a standard. Now putting a unit that's not a standard in there. But that's just something supplementative that I always put in, and it always helps that transition into data structures and into lists.
Thank you for letting us know that. That's awesome. Thank you.
Yep. Hopefully we got a whole bunch more good tips like that. We'll see. And then the last thing I just kind of want to mention is if you're doing anything else, CodeHS has tons and tons of courses that are built in Python. I don't know if we have any math teachers in here, but there's a lot of cool math courses. They're shorter courses. They're usually about a semester long, where you can kind of add it into your math class as you go. We're not going to be talking too much about some of that stuff today, but you can actually take a lot of the things we will talk about, and you can apply them to pretty much any Python course. And so we have our poll. Again, looks like half are just teaching regular old Python, and the other half is going to be teaching CSP, which is awesome that you chose Python for CSP, because that is the best language, in my opinion, to teach for computer science principles. Pseudocode looks just like Python, mostly, right, compared to other languages like JavaScript. And also JavaScript is the Frankenstein of programming languages, and I don't know why anybody would want to learn that. I'm sorry if that's your favorite language, but it's a mess. All right, so real quick, before we go into talking about building a Python unit and structuring it, do I have any questions so far about any courses? Looks like the Q&A is empty. We haven't covered too much yet. All right, perfect. If anything does pop up, don't forget, I on my other screen over here, I do have the Q&A, and we've got Lori and the rest of the CodeHS team monitoring that as well. So feel free to ask. I have lots to share.
Real quick, could you just repeat where you recommend the strings unit goes? So I think you said after functions and parameters in the CSP. Is that right?
Yes. Okay. So what you'll do is the strings unit from the intro to computer science in Python. You're going to take this strings unit right here, the one that's between functions and exceptions and data structures. You're going to take this strings unit. You can actually, you can look at it too. You don't need all of the stuff in the strings unit. You can actually, if you don't want to take the time, for my students, typically strings takes about a week and a half to 2 weeks. And that's with like a mini project we do at the end of the unit as well. So it's really it's not a lot, but you could probably just take the first 2 or 3 lessons that talk about indexing and how indexing works, and just some basic slicing that you can do in Python. You're going to take this right here and you're going to put it in between functions and parameters and basic data structures. In fact, if you plan on using the practice performance task here, I would put it right in between the practice performance task, but make sure it's before basic data structures. That's my preferred spot for it usually. You could do it before functions and parameters. There's no real reason to do that though, because while you're not going to be necessarily building functions, I think there might be a few where you build a few functions, but you could do it there, but there's no need. Perfect. All right. Anything else?
I do like the pseudocode aspect. Which unit is best for pseudocode? Is there any supplementing that you recommend for pseudocode?
So pseudocode's a whole beast in itself, because up until about 2 years ago, I used every College Board pseudocode question I could find, and there wasn't a lot. Like if you go and we'll talk a little bit about AP Classroom later, since we have some CSP teachers in here, there really wasn't a lot. Luckily enough, back 2 or 3 years ago, all I had were some of the units, some of the quizzes that were built in to the CSP unit, which there, I think in just about every single unit, there's at least 2, sometimes 3 little pseudocode quizzes that CodeHS has in there. So that way, when you're teaching them about functions and parameters, you'll have questions that have procedure questions written in pseudocode, and there's like a little prompt kind of explaining the differences. Now, in this course, there's no real teaching pseudocode. It's kind of just assumed as you go, like they're getting some pseudocode practice. So what I do, and we'll talk about this a little bit more when we get into the end of the unit and testing, but I'll take a day or two and we'll, before our first multiple choice test, which I only do in my AP courses. If it's not an AP course, I don't give text. Well, again, I'll talk a little bit more about that later. I usually do a full day where we talk about pseudocode. I'll print out the full pseudocode documentation, and I'll do it on full sheets, and I'll give everybody a packet, and this is their packet they get to use in the first few tests. And what we'll actually do is there's space on that sheet if you do a full page for all 6 pages, I think it is, of the pseudocode reference from College Board, and we'll actually go through and we will write the Python equivalent of the pseudocode on the sheet. So on their first test, they get to see the Python equivalent of that particular pseudocode. Also, to note, since we're talking a little bit about pseudocode right now, CodeHS has some supplementative stuff that you can add into. I don't know if it's, I think it's some supplementative stuff that you can add into your CSP course, where they've got a whole bunch of pseudocode questions. So we're not just limited to the 200 questions College Board gives us anymore. We've got a whole bunch of pseudocode questions. There's also Khan Academy stuff. And if you got more questions about that, we can talk about that a little bit more when we get into the end of the unit. But yeah, there's a lot. I wouldn't say a lot. There's probably about 7 or 8 little quizzes along throughout that entire unit, throughout that course that have pseudocode. And then CodeHS has a lot more that we can access. You can also use all of College Boards as well, which by the end of the year, I've used every multiple choice question still, because really multiple choices, that's one of the keys for CSP. All right, so just real quick, I'm going to give you an outline of what my typical Python course looks like. So I break it down into 3, if not 4 stages. Now, the first stage of any sort of unit or any lesson, right, is the covering of the content. We'll talk a little bit more about that in a second. Then students get the content, then it's mastering the content, and then it's producing some sort of summative product, right? So some sort of unit project, and that kind of varies if I'm teaching an AP class or a non-AP class. And then you have, if you're in CSP, usually we throw in a test. I'm project-based in any non-AP class, and that's mainly because just in the real world, in CS, you're not going to take a test. You're building projects, and so we build projects all day long. Now, let's talk a little bit about covering content. Now, from the way I see it, there's 2 ways using a CodeHS unit to cover content. There's the asynchronous, self-paced way of watching the CodeHS videos. So you could play them for the class. You could have the students work at their own pace and watch the videos to to absorb and to get the content. I've played around with both with that way before, and in some classes I use that. It really depends on the group of students. However, most of the time, what I do is I do something I like to call mini lectures. Unlike what I'm doing today, usually in my classroom, I don't like to talk for more than about 15 minutes, mainly because a lot of my students have the attention span of a squirrel. And so usually I call them a mini lectures. And usually while we're covering the content for a unit, we'll go through once a day, we'll have a mini lecture that is essentially, it's the same content as the video. And the videos are great. They cover all the content. There's everything you need there. But the one issue I see a lot of times with my students going and doing the self-paced videos is they either won't watch them and they'll dive right in. They'll just go. And if you've ever taught a CS class before, you know that you have a group of students who will skip through the video, they'll skip through the examples, and they'll start just ramming their head against a wall, trying to figure out what they're supposed to do for an assignment. And they're not picking up anything. They're not learning anything. They're just kind of trying random things out, not really making those connections. And so the reason I like to do these what I call little mini lectures, which they are the same exact content. In fact, I can show you what I do for these. So let's take a look. If we go into basic Python console interaction, and we're looking at variables and types, there's the video here that students can see. They can watch the video. Now, I'm not sure what free accounts have access to and don't have access to, but I'm pretty sure they don't have access to lesson plans. Is that correct? Or they don't have lesson plans? Okay. But if you don't have access to the lesson plans to pull the slides directly, there's still a way to access the slides. If you're looking at it before you play the video, there's a little button up here, and I also show this to my students as well. It's a slides button. You click it, and it gives you the slides, and you can put this up on your board, and you can go through the content as well. Now, if you're like, well, I'm new to teaching Python. I've never taught Python before. I don't really know this stuff. Watch the video and just repeat back what they say, do some of the assignments. And then as you go, your students can ask questions. And if you've already worked with some of it, or you know a little bit more, you can answer those questions. That's the big advantage of the mini lectures is you can ask questions to a video, but the video is not going to answer you. And so that way, I don't end up answering the same question 100 times from 10 different kids who all watch the video and then raise their hands individually. We can kind of answer them as a class. We can get a bit of a discussion going. And then we can also bring in examples from previous projects and previous things they've already seen. And so that's usually how my students get content, is they get the exact same content as if they were watching the video, but we do it in what's called a mini lecture format. Now, I have another suggestion, and that's locking students into the current unit. Now, this can be a little difficult for some of your advanced students. Almost all classes have a student or two, maybe three, maybe most of the class. I don't know if most of the class is ready to move on. I guess you can move on, but you usually have one or two students who are they're flying through this. They understand it. They're ready. They finished all the material and they're ready to go to the next unit. What I noticed my first year of teaching is I opened it up. I opened up the gates. I said, okay, here's what we're going to do. I'm going to cover one lesson a day. If you're ahead, you keep on going ahead. If you finish the unit, you go on to the next unit. I ran into a problem, and that was those speed racers, those kids who were just trying to check the box and get it done as quick as possible, were missing the little things. They started missing those little things. They might have finished the functions and parameters unit, but they didn't understand how return really worked. They just kind of plugged and chugged and got it done. And since they were ahead of me, they didn't really pay attention to the mini lectures. They didn't work through some of the class demos I did. They were already done with it, and they checked it. And then when the test came around, when they had a project, they hit a wall. And so what I tend to do is I will lock my students into that current unit. So they have access to everything we've already done, but I use the access controls in CodeHS to actually stop it at that unit. Now, you might run into the problem where, okay, a student's done. What does he do? Well, when we talk about some of the unit projects and some of those things, there's ways you can accelerate the students within that unit. And that keeps them mastering and continue to master those concepts and use those concepts. But you can also bring stuff from later units into that unit. That way they kind of have a bit of a foundation. Think of it like a pre-reading, right? Maybe you're inside of your control structures unit and they're doing loops and conditionals, and your project, they finish their project 2-3 days before everybody else does. You say, hey, why don't you take a look at this list documentation and incorporate a list into your program? They're not going to be masters of this. They're going to be learning it, reading from the documentation, which is how programmers do it in the real world, right? We read documentation to learn how to do something. And so they get to practice it a little bit. Then when they get into it, when they get into the next unit with everybody else, they've got some groundwork, they can move quicker. But that way you're not just letting them run free and kind of miss things, because that tends to happen a lot. Now, again, entirely a suggestion. But after my first year, I started just locking all students out per unit, just to kind of keep everybody on the same page. Now, when it comes to skill mastery, so that was content covering. That was teaching the students the content, letting them absorb the content. Mastering the content, that's pretty much the activities. If you're using a CodeHS unit, you're going through, you're accessing all the activities, the assignments, the challenges, you're working through all of those. Now, I tend to let my students, they self-pace this, they work through all of them. And what I usually do, and I actually made a bit of a mistake this past year, and it's something I'm fixing, is last year I made all of my deadlines extremely flexible. And we ended up rushing to get everything done before the AP exam. And that was a bit of a problem. But you can set hard deadlines, especially if you set up your class similar to mine, where I don't have homework unless my students don't get their work done in class. And so I have to end up setting hard deadlines. That way they'll actually get their class done. Something I've noticed teaching for the last few years is that if you give a week to do something that only takes about 2 or 3 days, but for the average student, but some kids need those extra 2 or 3 days, most of the class won't start on it until day 3. That's just, and so then you get classroom management issues and those kinds of things. So setting hard deadlines, extending it though, for some who actually need it, those kinds of things. And something I'm sure everybody does, because we're all pretty much CS teachers, and it's just actively moving around the room, and kind of helping students as you go. Now, we're going to talk, when we get back from our break, we're going to talk a little bit about some of those best practices that I implement in my classroom, which includes my style of check-ins, guided questioning, and how you can kind of help those students out as they go. But it can't be said enough when your students, so I'll do my usual class for covering content that day. It'll be a mini lecture, first 10-15 minutes of class, sometimes 5 if the lesson's really short. They've seen it, we've talked about a few examples, then they go into it. So at that point, I let them just skip the video entirely. They go into the check for understanding quiz, which if you have never seen them before, a basic unit looks like this. You have your video, you then have your check for understanding quiz. You've got a few examples, which I tell my students, don't skip through these. They like to see everything go green. That's a lot of students, they just like to see, they don't really care if it's done right, if it's done correctly, if it's done efficiently. They just like to see the little green bubble at the bottom. I don't care about the green bubbles for the most part, especially for the check for understandings. But the examples are really helpful. Like they're there for a reason. They're not just a click through. They're if you get stuck on the problem, the assignment, you go back and look at the examples, see how that concept is used, and then go forward from there. But I completely forgot why I was even over it. Yeah, that's right. So we get to these, we end up getting to the exercises, and most of the later assignments, they tend to have a lot more exercises. So let's see, it's got more than one. There we go. We've got a few down here, and as you continue to go on, you get more and more exercises. You can get some that are classified as challenges, which are essentially exercises on steroids. They're a lot harder, they're a lot more difficult. They take a little bit more time. They're like one step below what I would call a mini project. Now, something else I do for my class, now I don't really, I do it here and there. I don't do it, it's not something I do every single day. But if I do see, let's say I'm monitoring my class, I'm walking around the room, I'm answering the same question over and over and over again for the same problem. I notice 5 or 6 students are having problems with this one particular activity, this one particular assignment. What I'll do is I'll just quickly take a straw poll in my class. All right, raise your hand if you're having trouble with this one or you're not on this one yet. And if a good enough number of hands, pretty much more than about 3 or 4, all go up. Instead of me going individually those 3 or 4, what I'll do is I'll just stop and we'll do a class demo. And so this is really helpful when students are stuck on an assignment, when they're not really able to kind of get past it, and you're answering the same question over and over and over again. And even if that's not the case, doing class demos every now and then is extremely helpful, not just for showing them like what the answer is and how to really do it, but you also get to, when you do those demos, you get to instill a lot of those best practices that you, as a programmer, you would implement, right? And so if you're going to do demos, which I highly suggest you do, there's certain things you need to do. The first thing is, as you're working through it, you talk out loud. You say everything that's going on through your brain as you're working through the problem, right? So if you see, okay, here's the overall problem, I'm starting to see what this is asking. I need to break this larger problem down into X function, Y function. We're going to then combine those functions, make calls to them, and that way we get our overall output. All right, now let's go back. I've built the structure of my program. Let's go back and start implementing function X, right? You implement function X, you talk through how function X works, what your thought process is there. You stop, you build in little tests to see if the part you currently did works, right? Showing them that iterative development process. That is so important. So many of these students, and auto grading is amazing. I can't get enough of it. I love auto grading. I love unit testing. In fact, I actually teach unit testing in my 4th level. They essentially build their own projects and they grade themselves. It's beautiful. They build their own tests. But there's one disadvantage to that. And again, students love the little green checks, the little green circles. So many of them, especially early on in a Python unit, if you have sophomores, CSPs, my CSP class is usually full of sophomores. They won't leave the assignment. They will just click check code. And it just pulls up with what they think is like a checklist of what they need to pass. And it is, and they use that and they just try to implement those things. That's not how this should really necessarily be done. You need to read through the assignment. You need to then build in tests as you go, check to see if your certain pieces of your code are working, especially in those later on units, those data structure units, those extending data structure units, those challenges. They're not simple problems like you have early on. They're multi-step. You're building certain functions. After you build a function, build a little test for it. See if it returns the correct value. See if it does this. And as you're demoing it, do all of these things. Show them that this while it does take a step longer, in the long run, it's going to help you out, right? You're gonna know that this piece of code is working as intended, compared to this other person who just threw everything together and is running the code for the very first time, and they think everything's done. You get a list of errors that you have to then go back, sort through, and figure out. Doing that incrementally, step by step, iterative development process is so huge. The other thing, especially for CSP, because they have to be able to understand procedural abstraction for their performance tasks, it is a must. They have to. Doing demos and showing them how you take, and procedural abstraction is just breaking your problems down into smaller procedures and Python functions, right? In this case, it could be methods too, but you guys probably aren't doing object-oriented programming. And you'll see this written a whole bunch of different ways: function decomposition, method decomposition, procedural abstraction. It's all the same general idea. And that's taking the bigger problem and breaking it down into smaller chunks. Showing students how to do that, showing students like, hey, I need this method to do this so that it can cover this section of what I'm trying to do. I can use it later on and put it with this other one so that they can work with one another. But that way I don't have all of this stuff like smushed together. One of the things I tell my students all the time is building functions, right? It cleans up your code, but it helps with the debugging process, right? You can work if you work in smaller pieces, it helps out a ton. I believe there's even an example in one of the CodeHS videos or slides where they talk about how does a movie get made? How does an Avengers movie get made? Well, it's not all done by just one person. right? You've got different departments. You've got casting, right? You've got the script writers. You've got catering. You've got all these different smaller pieces. They all work together to produce an end product, right? And it's breaking that down and showing those students how to do that. Can't express how important that is. All right, so let's talk about end of unit projects, mini projects. It really just depends on what you want to call them. Now, there's a lot of different ways you can structure and you can build projects. But I've found something over the last few years that I've really liked a lot that kind of helps show that iterative development process and also allows students to kind of work through a problem in an actual development sort of way, where they're not just, and it kind of gives them some scaffolding and some structure. What I've started to call them is I call them tiered projects. And all a tiered project is, it's a project, but it's broken down into individual tiers. And so you can, my go-to is usually 4 tiers, right? You have your beginning level learner, your novice level learner, your proficient learner, and your distinguished learner. Now, usually you attach these different levels with grades, and I could do that here. I would say for my school system, like beginning learner would be a 70. That would be just passing, right? Novice learner would be an 80. Proficient would be a 90. Distinguished would be 100. But you can attach them however you want to. You can throw in more if you want to. It really doesn't matter too much. But what I do have is I have an example, and I'll give you an example here. And then I've actually got a bit of an activity where we'll take about 5 minutes for you guys to go in and try to create some tiers for a pre-built project. I have no idea how well it's going to go, but we'll try it out. But first, let's take a look at what I would call a tiered project and how it would work. So a lot of the stuff that we're going to be referencing in this workshop can be found at the very top in our workshop resources. And right now we're talking about Python projects. And so I've got a whole bunch of stuff here. A whole bunch of examples, 2 activities, any of this stuff that you want to take for your own classes, please do. There's some stuff that I've built off of other teachers in the past. That's kind of the whole point of these PDs, right? Is we're mostly isolated. We're mostly CS teachers in our own school. Most likely you don't have somebody else in the school. This is our collaboration, right? We can take any of my ideas, take anything, and feel free to always build off of it. Share them back with me. That'd be great, right? That's how, if you think about it, it's how open source things get better, right? It's this similar concept. But anyway, let's talk about some tiered projects. So this first one is a loot crate generator project. This is one of my favorite projects we do. You can do it pretty much after control structures. You can even do it after lists. There's lots of ways you can do this. Now, all it is a simple project where you're building a loot crate generator. So think of like a mobile app, right? Everybody's played those little games on their mobile apps. You wait 2 hours and you get to open the chest, right? And the chest opens up and you get X item of this quality, right? Like a common item, uncommon item, a rare item, an epic item, a legendary item. And then essentially your students are building this, right? They're going through and they're gonna build their own loot crate generator, right? So all you have to do is you just have to teach them how to use random numbers, which is pretty simple. You just need loops and conditionals. You can do it with lists as well too. And I have an example later on that uses lists and functions, but this can be done pretty early on. Now, the goal for the students in this project, right, is to create a loot crate that generates an item of X quality based on these percentages. I give them a couple of examples, right? They get to get creative, come up with their own items, but they have to tag it with the rarity level. And that rarity level has to occur, if it's a legendary, it has to occur 2%. If it's an uncommon, it has to occur 25%. And so what I do is I then, down here from my grading section, I break down what their grade would be as they go. So a beginning learner is generating everything that's listed above, right? Which is a super simple. They press the run button, it generates a random item from the crate. That's beginning learning, right? If they can use random numbers, they can press the run button, they can use conditionals, right? Boom, they get it, they got it, they're good, right? They show that they're starting to understand some of these concepts. My novice learner for this one would be all of the above, so it's inclusive of everything above it, right? But they ask how many times or how many crates they would like to open. This is now throwing in loops. This is showing another layer of mastery, right? So we're taking essentially, and this is the development process too, right? Before you go in and toss everything into a loop, what do you want to do? You want to test to make sure the thing works first, right? So you build a single crate, it opens. Does it open? It does. Do we get something of X rarity? We do. Cool. Now let's put it into a loop and ask a question, how many crates they want to open. So now they can open a whole bunch of crates, right? Following that, we have our proficient learner, which is all of the above. But now we're asking them if they want to open more crates after they've already opened it. And we've all done this. At least I've done this. You paid a couple of dollars for some sort of crate and you were looking for an item on a game, right? And you didn't get it. And of course you get sucked in. And so it's like, you want to do some more? Yeah, I'll do some more, right? That's essentially what this next level is, right? You're showing them how to hook the person in and so they get the item they want. No, not really. You're actually just teaching them while loops, right? But you're now integrating potentially some nested iteration here, right? You're throwing in a while loop and adding another question, putting a loop inside of a loop. You're adding another layer to it. Okay. And then the distinguished learner is going above and beyond that, right? And so that's taking everything else we've already done. And then on top of that, tacking in a basic level crate and a premium tier crate, right? Premium tier crates cost more money. Most of the time, we don't have money in this particular example, but they have better odds, right? And so the distinguished learner in this case would give them the option, hey, do you want to open a regular crate or do you want to open a premium crate? Okay, how many crates do you want to open? Opens all those crates. Do you want to open more crates? And it kind of goes from there, right? Now, the tiers that I built here, they're incremental, right? They start with the 70. Everybody starts with the 70. That's what I love about these tiered projects is no matter if you're going to get the 100, where's your starting point? Your starting point's at the 70. And that way you have students who struggle, they get to 70, they're on the 80 and the 90 and they're having some trouble. They've got something to fall back on, right? Let's say, usually most of my students get to the 100 by the end of it, right? Because they help each other out, I help them out. But you've always got something to fall back on. You've got something to work towards. It's not like, hey, do this part and then go do this other part, right? No, it's take this first step and then take the next step and just keep taking those steps as we go. So let's see if this works. So what I've done is I've built a little activity for this workshop. That way you guys can not have to hear my voice for about 5 minutes. And you get to try out maybe building a bit of a tiered project. So I took because I wasn't sure where everybody's level of Python knowledge was. So I went with something really simple. So right below the loop crate generator, I have some directions here. Now this is a base set of directions for a very, very simple assignment that could pretty much be done after learning about variables, loops, and conditionals. Okay, it's a guessing game, really simple. Okay, directions are write a program in which the program will generate a random number. The user tries to guess which number the computer will choose. If the user guesses correctly, the user wins. If they guess incorrectly, the computer displays a message to the user too high or too low. That is the very baseline, right? In fact, my grading here says beginning learner, the computer generates a random number and the user makes one guess. The computer then tells them too high or too low, and then displays what the number is. It's your base level. I went ahead and also filled out a distinguished learner. This will kind of give you some hints as to what you might want to put in as a novice learner, as a proficient learner, because your activity here in a second is going to be to go ahead and fill out novice and proficient learners. A distinguished learner, right, is a two-player guessing game. You guess until you get it right. When a player guesses the number correctly, the program gives them a rating based off of the number of guesses it took. And the winner, right, is determined based on the number of guesses they took. So if you took 5 guesses, it'll call you a super genius, right? And if your buddy took 7 guesses, it'll call them just average. And then it'll say, hey, player 1 won, right? Something simple like that. So what I'd like for you guys to do, and I'll put a little timer up here just for about 5 minutes. I've got 2 examples. I've got an example set of code that shows what the beginner learner would be. I've got an example set of code down here that the distinguished learner might look like. And if some of that code scares you a little bit because you're not too familiar with Python, that's okay. You don't have to understand it all. You can run them. I think they work. I built them yesterday. Hopefully they work. I've tested them. And then what I want you guys to do after you've taken a look at both these examples is in this activity here, it's just a simple text document. Just go ahead and try to create a novice learner tier, right? And then create a proficient learner tier, something that steps towards what we essentially want, which is this distinguished learner. So that's our goal, right? Is to get there. So how do we get, what are the steps we take to get from beginning learner to get to this distinguished learner? How can we break that down and work incrementally? So I'll give you guys, let's see if this at the time works. I'll give you guys 5 minutes. It'll take 5 minutes. You guys go ahead and give that a try. And then we'll see what some of you guys came up with. And then we'll take a look at how I broke my tiers down for this particular project. All right, so let's take 5 minutes. And if you've got questions while we're doing this, feel free to ask. I am here for all of you. We need another 3 minutes, or can we just call it in about 1 minute? Again, I have no idea how long this is going to take, but let's give it another minute. I'll give you guys about 1 more minute. That's how I am in my classroom too. I have a big, super loud timer. It's called an iScreen, but and that's also another little tip for you. If you, especially if you're teaching CSP and you're getting into all your non-programming stuff, get a timer, right? Get a timer. I have a magnetic one. It's big. You can see it from anywhere in the classroom. It's loud, and I put it up on the board when they do their warm-ups beginning of class. Set the timer, and you are working on an activity for 10-15 minutes and you need to transition. Timer. That timer, it keeps everybody moving. People can check the time. It keeps them from doing and dallying. And it keeps me on track too. Except I do change the timer. Like I'm like, okay, time's about to run up. Do we need an extra 3 minutes? They'll say, yeah, we'll add 3 minutes onto it. Or I just see them all twiddling their thumbs. Like, okay, we can end it early. I'm never good at judging time, but timer, super helpful. Ooh, okay. All right. So let's talk for a second. Let's see. Did anybody come up with anything they'd like to share for novice learner? Anything that they found that they might put into place right at one step above the beginning learner? If not, it's cool. We can talk about my tiers. Anything for novice proficient before I give you guys a couple of examples that I come up with? All right, cool. Let's take a look at what I've done. So I kind of tricked you a little bit. I said build a total of 4 tiers, right? We have 4 tiers, and I was making work with 2. My project for this one is actually 6 tiers. I actually have 6 steps. You can easily cut some out, but I build in 6 steps for this particular project. And so I had everything from beginning, novice, intermediate, proficient, advanced, and distinguished. I had no idea how to come up with like different adjectives for the learners, so I just use ChatGPT, useful stuff, right? So the types of learners are all generated from there, but mainly because I don't have types of learners, I just have grades, right? So this is the 70, 89, but I figured this will work a little bit better for y'all. But anyway, starting one tier above the beginning learner is going to be same as above, but make 3 guesses, right? So we're taking just a single guess, right? Which the guessing game is a single guess, one guess. We're now asking them to do it, to put in a forward. They repeats 3 times, they get 3 guesses, right? Now there's a bit of a problem with this one. What if they get it right on the first try? Well, if they get it right on the first try, it's not the best. Then that's why you can kind of compress novice and intermediate together. But intermediate is doing the same thing as well, but an unlimited number of guesses. So this is using a while loop. You could put these 2 together if you wanted to. Proficient is the same as above, so including a limited number of guesses. But now we're adding in a counter. So what we're doing is we're making sure our guessing works. We can guess until we get it right. Now we're adding an extra variable that allows us to keep track of the total number of guesses. Above that, we're going to do the same thing. We've already done counter our number of guesses, but we're going to give them a rating. So now this is forcing them to use essentially a group of conditionals, right? Probably if, else, to check the number based on the number of guesses it took to then give them a rating. I believe in the more advanced example, I have a function in there that actually does that. And again, you can do this project without functions. The example I put in there was just, it's easier for me to write with functions because functions make the world so much easier. But you can do this without functions without a problem. And then finally, the distinguished learner, which is the same thing as everything else, except it's a 2-player game. The winner is whoever guessed the fewest amount of times to get to their number. So tiered projects, I love them. They're awesome and amazing because you get everybody starts in the same spot and you're just working up that iterative development process. Now here comes the problem with, especially if you're locking students in per unit, because usually one of these tiered projects I tuck in at the end after we covered all the content for that CodeHS unit. We got a tiered project, right? And so they'll do the tiered project. And if some students, they'll finish the tiered project in a day. I have some students, it'll take them 2 or 3 days. What's the solution there? If you're keeping them all within the same unit, well, it's coming up with some way, some way to accelerate them within the unit. Now you can do project add-ons, which in my case is extra credit. My first year of teaching, completely against extra credit. I found in the 3 years since then, some of these kids, the only way to motivate them to do anything past what the minimum requirement is to give some extra. And so I do extra credit. There's tons of ways you can do it. I have, you don't have to give extra credit. I have this another teacher tip for you, especially if you're teaching a CS class where all the kids chose to be there. Get nice, cool, geeky vinyl stickers, superheroes, Pokemon, whatever. I have a sticker bucket. They die for that sticker bucket. They love that sticker bucket. But anyway, there's tons of ways to really kind of incentivize them to go further. But you might be saying, okay, Rob, well, they can go further, but go further doing what? They just built a guessing game. What else can we do? We're in console. Well, there's actually a lot you can do with console. And console-based Python is awesome, right? You don't need graphics for teaching CSP. You don't need graphics for really getting some more stylistic elements into your program. In fact, you can do it with console. You can build it all in console. And it's this thing, it's called ANSI, right? I forgot what it stands for. I know what ASCII stands for. I completely forgot what ANSI stands for. But it's essentially, it's these strings that when it's read by a terminal output or a command line, or it's read by the console, the string itself changes how the console output looks, right? And so what I've got is, if we go back over to our developing Python project, is I've actually got, I built this module, and it's called Cool Console. Now it's modeled after an actual Python module called Color Run. Now this right here is a resource for you to use in any of your classes, anytime you want kids to kind of spice up their projects a little bit. And what it does, and I've got all the documentation here, it shows you how to use it. I'll walk you guys through a little bit of it. But all it is it's a, it's actually, you can see it better if you change the console thing. If you didn't know, the settings on the left-hand side of the CodeHS editor, you can change it to a dark console thing, and the colors actually look a lot better. But if we just run this example program, you can see, look at this over here. We now have a console, right, that prints out in different colors, has different backgrounds. We have different styles, bold, dim, italics, underlines. We can do all of this in console-based Python. We can do it all. We can do it in pretty much any console language. And so that gives you a way to kind of just go a little bit further, right? Okay, cool. You've built this guessing game. What's next? Well, what can you work on? You can add some stylistic components to it. And this will actually, the way this is set up and this is built, it'll actually kind of get them used to utilizing external code. Okay. Now, how do you use this? Well, it's pretty straightforward. Just like you would import random from the random module to get generate a random number, you have to import the code. Now, this isn't some module that's built into CodeHS's development environment, right? So this is, to actually do this, you have to create a new file. So you'll have to click right up here, you'll click new, and you'll call the file console.py. And that's all laid out here in both the README and this right here. The whole setup walks you through how to actually use Cool Console. Now, once you've created a file, an empty Python file called coolconsole.py, you just take the code that's in here. You literally just Control A, which if you didn't know is a keyboard shortcut to copy or to highlight everything in that particular file, copy it, and then paste it into your version of Cool Console. All it is, 4 classes, right? It's 4 super simple classes. I tried to keep it simple, so if you want to explain this to your students, you can. If we try to build this like a real module, it gets way more complex than that. So I tried to keep it simple, and all it is it's 4 classes with static variables that all have the ANSI equivalent for what that value should be. And if you're like, okay, this is cool. I have no idea what you started talking about 2 minutes ago when you started saying classes. I have no idea what you were talking about when you were saying ANSI and ANSI strings and static variables. It's pretty simple. We can actually look at the base version. I have an example of, without using Cool Console, what it would look like. This string right here, it's an escape sequence. It's an escape key that just essentially tells the following text in console to be the color black. This one right here tells it to be the color red. And what I've done is you can do all this. You don't need Cool Console to do this. You can literally just put those strings and concatenate them together with the string you want to change the color, the background color, the style. You can use the appropriate string there, except that doesn't look clean. It doesn't look neat, right? It's kind of hard, like, okay, well, what color is blue? Well, blue is 34. Well, how am I supposed to remember that? Well, with Cool Console, you don't have to do that. You can see blue, the string for blue is here, right? So if I want to make text blue, right, all I have to do is I just, from Cool Console, so that's saying from my Python file Cool Console, import these 4 classes. You don't have to import all 4 of them. You can just import one of them if you're just using one of them. But 4 stands for foreground. And so we want to change the foreground color to blue. So we're using the foreground color blue, and we're going to change this text to blue. Pretty simple. And then over here, we get a blue text. Easy, a lot simpler, you don't get these crazy strings. You kind of get to abstract a little bit, which you can talk to your students about that, especially if you're teaching CSP, because abstraction is one of those big ideas. And there's tons of stuff you can do. There's even things where you can clear the screen. And so if you actually run the example, you press enter and it clears the screen and resets everything. So you can essentially turn these console projects, these projects that are cool, right? But okay, we guessed too high, too low. If it's too high, maybe it's bright red. Maybe we guessed too low, it's bright orange, right? You can add all of these things into and accelerate a lot of those students by letting them utilize Cool Console. So feel free to use this. Take this. There's documentation for it in both the README and the assignment in here. I also went ahead, and this is one of the only ones I've done this for so far. This is also in the what's it called? Let's practice. Problem bank. It's in the problem bank. So if you ever need this in this course somehow, it's called Cool Console. It's in the problem bank. You can access it. Super simple. If you want to take it, you want to make it better, make it better. Just share it with me, because I like when my work gets made better, because then I get to use it too. The other thing is adding ASCII art. All right. You don't know what ASCII art is. It's pretty simple stuff. You can have them do a multi-line string, right? And we can just type it in here. We can change it to whatever style we want. They can take this whole string. They can use a multi-line string. They can give like a title to their project. A lot of stuff you can do to add kind of style points to your projects, and that kind of help keep those kids working on the same projects, not going too far ahead, but keep them engaged, keep them working, keep them practicing a lot of those concepts. The other thing you can do is input validation. So in CSP, in the regular Python course, we work with try except. In computer science principles, try except isn't in those standards, so it's not covered. But you can accelerate them by showing them how to check for errors, and if you're asking for a number, if they type a letter, to not just break the program, but to say, hey, invalid input, try again, right? You can add all kinds of things. Now they're picking up another skill while they're still working on the same project the rest of the class is working on, because I know as a teacher, especially when you have kids doing all different kinds, it's hard to manage the class. So keep them together, add these project add-ons, add these extra credit things. You can incorporate, like I mentioned earlier, like you can pull lists into the next project. Just give them the documentation, lock them out of the CodeHS unit, but give them the documentation, say, hey, try this out, right? Now, you can, if you have a student who understands everything, has done all of this, still got 3 days left, you got nothing else to do with them. Hey, you can't find another spot for them, move them on to the next unit. It's not like it's not a rule for me. It's more of just like a guideline. Keep them together if at all possible. If you have that student who's way above and beyond, right, they're ready to go, you know they've mastered the content, you know when you let them go free that they're actually going to pick up on all those concepts, let them go. Let them go. And we'll take our break here in just a second, but first I just want to mention testing, because I think this will kind of put us right where we need to be. For the half of you that aren't teaching AP computer science principles, my suggestion to you is don't give tests. There's one thing I've kind of, especially if you're trying to get your students college ready. I'm a little over a year into my master's program. I have not taken a single test for any of my CS courses, not a single one. Everything's a project. You go out into the real world, maybe they're not going to be taking tests, they're going to be building projects. So focus more on those projects. Yes, tests can be easy, right? You pull a test from someone, you give it to them, boom, you have a summative grade. Yes, projects take a little bit more work for us on the front end. It's worth it for them though. They get a lot more out of it. They get to develop things with each other. They get to collaborate. They get to really apply those skills. So if you don't have an AP test at the end of the year, my suggestion is don't give tests. Quizzes are fine. I don't grade quizzes. If I do give a quiz, I don't grade it. The quiz is formative for me to like get an idea of where they're at, mainly because if I give a quiz and it's graded, I'm not going to get accurate information. They're going to be asking their neighbors, like they're just going to try to get the best grade possible. So for quizzes, I don't even grade them. I get an idea of where they're at, but I don't even give a lot of quizzes. That's because I do check-ins, which we'll talk about when we get back from our break. But if you are teaching APCS, you can't get around it. In May, they're taking a 70 question multiple choice test where roughly half of the MCQ is pseudocode. So that means you have to test throughout the year. You have to get them ready. You have to practice. And like I mentioned earlier on with the pseudocode, there is tons and tons of pseudocode practice in CodeHS now. There's stuff that's built into every unit. There's also supplementative resources you can pull and supplementative pseudocode questions you can get. They're great questions. Khan Academy has great questions too. The only thing is that if you want to make sure that they're ready for the AP exam, don't neglect AP Classroom. If you've ever taught an AP class before, you know AP Classroom is a wonderful resource to use it. That's because all the questions in the question banks, they all come from previous tests and or practice tests. Yes, CodeHS has some great pseudocode questions. Most of them are perfect, but if you make sure you do the AP Classroom stuff too, because that's coming from the people who are making the test. And regardless, it's going to be the closest question. That's really not much of an issue in CSP because pseudocode is very, very simple and the questions are very, very simple. When it's the CSA is a little bit harder because CSA questions are a whole, there's something else. But yeah, if you can avoid it, don't give tests. If you can't, my split is 50-50. Mainly because we have a performance task, right? They're 30% of their AP grade is their performance task. Roughly half the multiple choice, 30 to 35% is pseudocode. That means for coding, half of it's a project, half of it's a test. That means my first semester when we're doing all of our programming, we have half of the summative grade are projects, half of the summative grades are tests. So we'll do some of those tiered projects. I'll actually, some of the simpler ones that take a day or two, those will just be classwork assignments. Or I'll have some larger ones that maybe they're doing pair programming for, maybe they're doing something else, which we'll talk about pair programming when we get back from break 2. I split it 50-50. That way it matches the AP exam. But again, I can't stress it enough. If you don't have to give tests, don't give tests. Not in the CS class. But again, that's up to you. That's to your own discretion. Before we go to break, any questions, anything that's on anybody's mind? It looks like we got what magnetic timer do I use? Okay, that's a wonderful question. Found it on Amazon, got my school to buy it for me. It's way too expensive, but it's called an iScream, kind of like an iPhone, but iScream, like you're screaming. It's a big one. Over break, I'll see if I can find a picture of it. And can you unlock a unit for just one student and not the whole class? I think so. Yeah, I think you can individually assign. Here's another thing too, and I don't actually have this in my slides. Let's say you don't want to move them on to the next unit yet. There's a whole tab in CodeHS called the practice tab. I think we mentioned it for something else, but the practice tab is awesome. The practice tab lets you go through and you can give them extra supplementary material for that particular concept. But yeah, I'll let Lori or somebody from CodeHS answer that, because usually if I release it to the whole class and I just tell that one student to go on, because most of them know that they're stuck on that unit anyway. I'm not really, if they're sneaking off at home to go and get ahead, cool, that's fine. That's fine. So it's not much of an issue.
I will mention that access controls are a pro tool. And so if you are a free teacher, you don't have access to lock or unlock activities for students. Although there are some other things you might be able to do. I know it not as convenient, but you do have ability to customize. So there's always a possibility you can remove or add things in as you need them. So
I will tell you what I did, and this may not be the smartest way to do it, just to let you know, but I had students that I knew they were phenomenal computer students, and I made an extra class of the same material for them that was unlocked like for two units. And so when they got done with 2 units, where the other class was only getting done with 1, where the rest of the class was only getting done with 1, then I would get together with them and talk to them and see where they were at and if they knew what they were doing and check everything. And then, but that's how I did it. I don't know if it's good or not, but I knew my students.
That,
so, yeah.
I love that idea. In fact, I have a section here from last year, Mr. Kramlich's overachievers. It's essentially anytime, because you always, every class has those students. You have those students who understand it, get it, they want to learn more, they want to do more, and maybe you don't want them. And this is maybe another solution for you, Ken. Maybe you don't want them going to the next step yet, but you want them to maybe practice some other CS concept. CodeHS has tons of stuff. I had students who were finishing their Python work early and were learning HTML and CSS because they didn't get to take my intro class. And so they were in that overachievers course where I just literally have a whole bunch of different content for them to work with and to access. So yeah, there's tons of ways to accelerate. All right, I think we'll go ahead. We'll come back at 1:20. We'll take a 5-minute break and then we'll wrap everything up.
I had my cybersecurity classes. There was some students that really got ahead, and I had them do some like Python. I had some Python stuff for them to do, and because I used the CodeHS cybersecurity, so I had some CodeHS for them to do in Python or like Java or what. I just picked some neat stuff for them to do, and they had a ball doing that when they were, like when they were ahead. But yeah, I have the Overachievers Club. I love those.
And this is, it's not CodeHS, but if you have some kids that are really interested in some cybersecurity stuff, CyberStart America, if you have a license for it, which they actually have free licenses in the state of, I think it was the state of Georgia, or maybe it was nationally last year. So much fun. It is something else entirely. I got addicted to it. We had a whole leaderboard going in class. Students were trying to beat me. It was a lot of fun. Really cool stuff. It starts really simple too. So if you have kids that are interested in like that cybersecurity side of things, CodeHS has got some great stuff, but there's also some stuff that CodeHS can't necessarily do that can be done in CyberStart America, which is some really cool hacking stuff. Highly recommend that as well.
I would love to have the link to that. So you're gonna have to send me the link somehow.
Yeah.
I'm driving. I can't type it.
I'll have it's not part of it's free, but the other part's not. And they, like I said, I think they had free licenses last year for K-12 education. I don't know if they'll do it again this year. But we also used it as extra credit. But I'll make sure I'll get a link over to Lori, and I'll make sure she adds it to somewhere. Now again, it's not there's Python stuff in there. It's mostly just hacking and cybersecurity stuff. Let's see. Well, they still on break. Svetlana, I see your question. I don't think they have anything on CLI. Command line interface would be a great tool for some of those overachievers, but I don't think they do. I think they can correct me if I'm wrong, but I think their editor is a little limited in that aspect. If you do want to do some command line stuff though, that's web-based where they're not accessing stuff from the machine, because my computer lab's actually locked out. Like my kids don't have access. Well, they do. There's a workaround, but like the county doesn't allow for them to work within the command line. But there's other stuff out there. Like Replit. Replit gives you full access to the shell. And so you can do some stuff in there. But I think they might have something. But All right, well, we'll dive right back into it. Before we do that though, Svetlana, the only CLI I've ever done has been out of like physical Linux textbooks. So nothing I know. Maybe some other people have some good resources. I'm not too sure. Well, you guys don't have any CLI stuff in CodeHS, do you?
So we do actually have a few CLI activities, not a ton of them, but we do have some. And one of the things that I've done, and this is a pro feature, and it's one of the few customization things that is a pro feature, but if you want to create more CLI kind of things, you can actually fork those activities and you can alter the activities and you can have kind of, it's almost like a virtual console right there where you can try out some things. It's kind of cool. So
Okay, I know what I'm doing next year in my 4th level class. I had no idea you guys had that. That's
yeah, we have just
that's
a few. It's something I actually just started playing with a few months ago because the school asked for it and I thought, I wonder if I can do this. And it looks like you can. So I'll send you those links too, Rob.
yeah, is it a Linux kernel?
It is built into the console itself or into our
We had a thing on that the other night. The gentleman forked stuff
yes,
all the time. It was pretty cool. I loved it.
it is a really awesome tool. That's a really powerful tool. I use it all the time when I want to build something or I'm not sure how something should look. So I just start with a template, I fork it, and then I go from there. So saves a ton of time. So I'll grab some of those links and drop those into the workshop link doc. I think that would be a great place to do that. And I just had to mention too, Svetlana, I love Gen Cyber. I went as much as I possibly could. There is one in South Dakota at Dakota State University that gave us so many things. I came away with robots and drones and programming books and Raspberry Pis and Arduinos, and it was the most amazing experience. And I learned so much from Gen Cyber. If you all have a Gen Cyber near you, go. Absolutely enroll. Travel to one if you have to. They are so valuable. I loved that experience. I still use things today with CodeHS that I learned from Gen Cyber. So it's a little plug there. Yes, they do. Many of them do stipends. Actually, all of them do stipends. I don't know if there's any that don't. They pay for your costs, usually your travel costs. I'm blown away at the things that you get. So it's been really, really cool. Okay, I'll be quiet now.
Oh, you're good. You're making me want to go now.
Oh, you should.
We had something similar. It wasn't Gen Cyber. We had something. I didn't get to go to it because we were actually out of country. But it was something where they were using CyberStar, but like the University of North Georgia, it was like a whole week-long camp, stayed in the dormitories and stuff. Wish I could have gone, but yeah, that stuff's amazing. I just wish I had a cybersecurity class. I could actually bring that stuff to you. I don't. But all right, let's dive right back into it. So on the back half, we've got a little more than half an hour, which is about what I planned. So hopefully this works out. So this next section is just well, the first part is going to be some tools that CodeHS have to make your life easier, because here's the thing, right? You're a computer science teacher. There's no reason for you to be bent over grading things day in and day out like an English teacher, right? We have the ability and the tools to automate a lot of this stuff, and learning it on the front end really helps out a lot. And the beauty of CodeHS is they've actually, in the last couple of years, have developed a really easy way for you to create your own assignments that are auto-graded and without having to learn unit testing, which for some people, there's a bit of a learning curve when you're building unit tests, and they make it super, super simple. So let's go ahead and let's talk about some of this unit testing. So let me talk about that to our course. If you were to, let's say, for example, you wanted to build an assignment that has your students testing or checking to see if they understand how functions work, and you want to build your own custom assignment, you want to build your own custom project, something along those lines. instead of creating a coding exercise, right? What you want to do is you want to create a practice problem. Now these are auto-graded, so there's auto-graders that are built in. Only problem with that so far is we're limited in the languages, mainly because this is the only stuff that they have set up for unit testing and input output testing. I'm not sure. I think it's just unit testing. Correct me if I'm wrong. But you can just click on, if we're doing Python, we click on Python. We create our assignment. So this will be function test. We're going to pick a topic. We're going to be testing functions. We'll save that. Now here is where we get our solution code. So this is essentially where you would paste in your function. Now, your starter code, for all this to work, your starter code has to have those functions in there that you pre-named. Because what's essentially happening is when they press the check code button, it's running a unit test file. That unit test file is checking to see if this function with this input has this output. Pretty simple. And so if we did, let's rename that to test, and we just want to take a number, actually it's called add to. So add 2, and then here this is going to return num plus 2. Okay, so that's our solution code. That's what they're building. We're going to save that. And let's add a test case. So our first test case might be add 2. Well, 2 plus 2. We'll do add 2 with 2 passed in as the parameter. Let's do 1 for 3, we'll do 1 for 0, and we'll do 1 for some crazy high number. We don't want to go over to that. And you can choose to hide them. So if I'm building something like this, what I'll do is I'll give them the simple ones. So when I'm building test cases, I always give them like the super simple ones that should work, and then I give them like the crazy one that's going to really test every angle of their code. And I'll usually hide that one, mainly because I want them to be able to do it correctly, not just work backwards from the tests. They can do that for the earlier ones, but for some of them, I like to hide some of those tests. So you just click save and continue, you finish it, you configure it, you preview it. What we get here is we get the function right here. And so if we did something like num plus 1, which is not what this function is supposed to do, we run our check code and we fail all of our tests, including our hidden test. If we come over here, we run it, we check it, we pass all of our tests. Super simple unit testing. You don't even have to worry about creating a unit testing file. It does it all for you, which is extremely convenient for Python. I think it's JavaScript and Java, especially Java. Java unit testing is not fun. You can do a lot with it. It's really cool, but learning that whole thing took me way too long. But that's built in. Now, I will make a suggestion that just because you have the ability to create test cases and to create unit testing for your students, when I use these, it's when I create custom classwork assignments. It's not for a tiered project, usually. Sometimes it is. The only issue with tests is you limit creativity in some aspects. They're not designing the program. So especially if you're testing with functions and you're using unit tests on particular functions, you're telling them, hey, you have to have this function, this function, this function, and this function. Problem with that is if they're working on procedural abstraction, you're trying to teach them how to break a problem down into smaller pieces. Doing test cases kind of already gives it to them, and you kind of miss that. You miss the creative aspect of breaking the problem down. Very useful tool. Just make sure that you kind of keep up with that, and that you use it in appropriate places. But that's what I love to brag as a CS teacher. To all the people who are like, "Oh, you're a teacher, so you're like grading papers and stuff." No, I don't grade things. I build programs that grade them for me. I give them to the students. It takes me 2 minutes, and I'm done. Right? It's an advantage of being a computer science teacher. You build programs to do the grading for you. Now, the CodeHS gradebook is how I do a lot of my classwork. Way too many tabs up over there. That's fine. We'll make it work. Okay, so if we take a look at our gradebook, so this will have everybody that's currently in our class. We're looking at the very first unit. Now, this is not what you will see. If you went ahead and you ran this on one of your classes, you won't see this nice condensed section. I actually set this up earlier and I forgot to reset it. What you'll see is all of these boxes will be checked. Right here, display all. Okay, actually, just all 4 of these checked, and then we click save. So this is what the default gradebook looks like. It's got videos in here. It's got your I might have to check the videos. Yeah. So it's got pretty much everything that's in the lesson in the grade book. You can kind of get a little overwhelming. Mainly, I like to condense this because I don't grade the check for understandings. Those are kind of formative, like where I'm at. Because if I start grading them as I finish a mini lecture and I say, okay, let's get to work, they're not going to answer them. They're gonna look at their neighbor and say, hey, what answer did you get for this? And it doesn't show me if they picked up what they know. So when I do my gradings per unit, usually I do it on a per unit basis. I'll configure my gradebook where I'll take out everything except for exercises and challenges. And then I'll save it. And that way I end up getting a more condensed gradebook. It gives me the stuff that's actually there. Now, anything that's auto-graded will automatically populate as green. Anything they haven't even opened yet will populate as gray. And anything that they've opened but have not finished the auto-graded for will pop up as yellow. I believe dark green, there's a key up here. I think dark green is finalized, meaning it's not an auto-graded assignment, meaning you have to go in and you actually have to manually grade it. That's not the case for most of them. Most of them are auto-graded assignments in a lot of these Python courses. But that's how I do my grading. Some people, and it's up to you. It really is. It's how you want to grade. Some people will do like the entire unit. They'll just keep the entire thing up there, and then whatever grade it says over here on the left-hand side, at the end of the due date, that's what they get moved over. But to me, I like to focus really on like the content. Like, I don't care if they get points for watching the video. We covered the content together as a class. I don't care if they got all the stuff right or wrong for the check for understanding. In fact, I want them to get stuff wrong and not just look at the neighbor or ask somebody what the answer is, because they're not seeing what they're missing there. I found that when I started taking those check for understandings out of the grade book and not grading them, I had a lot more kids ask me questions. When they got something wrong, they'd raise their hand and say, hey, why did I get this wrong, Mr. Kramlich? And then we can talk about the concept and we can go back over. So that's how I use the grade book. Like I said, a lot of options, but it just gives you a lot to work with. But it is something that I do with my kids. I strictly focus on the assignments and the activities. Mainly because it's not a one and done kind of thing, right? You get to iteratively develop things. If that means by the end of the unit, most students have a 100 for that classwork, great. That means they've all gotten there. Just it's something I've kind of picked up on over the years, is just kind of giving those incremental steps, letting students have that ability. So those are some of the cool grading tools that CodeHS has to offer to kind of make your life a little bit easier, a little bit more efficient. There's obviously a lot more that goes on there, but this isn't necessarily a particular course just on grading. I just kind of wanted to highlight a few of those things. Now, something I did, and I kind of added some of this stuff a little last minute, but there's some things I've started doing over the last couple of years in my classroom that I think have made a huge impact on my students' abilities to program, to ask questions, and to really excel in CS. And the first thing is something all teachers should really try to do. It's build that rapport. One of the best ways to build rapport with every single one of your students is to just greet them. When they come to class, if you can, stand at the door and greet them by name every single day, 6, 7, however many classes you have every single day. Letting them know, hey, I know your name, I know who you are, I am glad you're here, have a smile on your face. It makes a huge impact because when they come into the room, they're ready. It gets them ready to go. They know they're appreciated. You know, you're just not another number in the classroom. I had high school teachers that by the end of the year, I wasn't even sure if they knew my name, right? And so building that's the first big step there. Now, one of the main reasons I put this whole section in here is because a CS classroom looks a lot different from your average everyday English class, your average everyday math class. That's because when they're doing self-paced work and they're working on an assignment, maybe you have 5 kids in that class period, that 48-minute, that hour class period that have questions. Maybe you have 10 kids that have questions. You go around to help, and you know this if you've been teaching CS before. As soon as you get to that first question, you help that kid debug their code. Maybe it takes you half a second to find a problem. Maybe it takes you 5 to 10 minutes. In some cases, some of my classes, I'll have 10 kids that have questions, and I'll only get to 5 of them, right? I only get to 5 of them that day. And because I can only get to so many, because debugging code sometimes takes a little while, showing them those best practices sometimes takes a little while. And you always have those kids who are constantly raising their hand, constantly asking a question right when they right when they run into something, they don't have the skills to be able to rubber duck debug or and those kind of things. We want to give them those, but they're still going to constantly ask those questions. You're always going to find in a CS classroom that there's a group of students, 5 or 6 of them, that ask a question every single day. You spend most of your time working and talking with those students. Problem is, you've got the other half of the class. You've got some students who won't say a word, who won't talk to you, who won't ask questions when they're stuck on something, and that can make it hard to gauge. And so what I started doing a couple of years ago is what I call check-ins. And I have a check-in day. I do it once a week. Depends on what day of the week, but I do it once every single week. This is a day where we don't cover new content. Or if we do cover new content, we cover it quickly and then we go into our check-in day. What I do for check-in days is it's usually a self-paced day when they're working through some content in their classroom. And I say full stop on questions. The girl or the guy who's constantly every day asking questions, I say, I'm not going to answer those questions. What I'm going to do is I will answer those questions, but you get one shot. You get one shot. Because what I'm going to do today is I'm going to start at a random seat number, right? And I'm going to go start at that random seat. I'm going to sit down next to that student and I'm going to check in with them. I'm going to say, how's it going? What you working on? Do you have any questions for me? How can I help you? What concepts are you getting? What aren't you getting? And you'll actually find that there's students in that classroom who will not raise their hand, but they're stuck on stuff. They don't get it. They don't understand the concept. And by kind of forcing them really by sitting down next to them or walking over to them and checking in with them, every single one, you're kind of taking that, you're kind of giving them the opportunity to ask their questions, because there will be kids every day. They'll raise their hand. I got a problem with my code. You spend 15 minutes over there. You get to like 2 or 3 more kids. That kid's having the same problem, but he's not going to speak up. So check-ins have changed how I run my classrooms. And you can even take it a step further. You can make a check-in a formative grade. I do this in my 4th level class. What I'll do is it's a game design class for the 2nd semester. So like we'll do a full like 3-week long project. It's like, okay, I got 3 weeks. We got 1 summative grade. I got to have some formative grades in there. So every week we do a check-in and I say, hey, for this check-in, I'm looking for these 3 things, right? And during that day for check-ins, I pause all other questions. Nobody else can ask a question unless I'm at you for your check-in, right? And that's the kind of give some equity to the classroom, give some equity to those students who don't get access to you because their peers keep hogging all day long. It happens in every CS class. So check-ins are huge. They also help a lot with some other stuff, which we're going to talk about here in a second. Some academic dishonesty stuff, which we'll talk about in just a few minutes. Now, this is not always possible. However, the best class size I can have in my classroom is 20. And the reason it's 20, I have 28 computers, but I love having 20 or fewer students. Every teacher loves having fewer students. That's just a fact. But if it's 20, it's perfect because I've actually developed a way to set up my classroom where I have the ability to sit next to students. Something else, maybe this doesn't apply to all teachers. I'm 6'5", okay? So my kids are sitting in a chair, lower to the ground. I come over to help them. I don't sit down in a chair. I'm leaning over them. It's intimidating. It doesn't feel like we're working together. I'm kind of more just dictating. So if possible, I actually set up my classroom to where I can sit next to every single student. So this is an example layout of what my classroom looks like when I have 20 students. All the green squares, those are 20 students. I put them all in. Now they all have an elbow buddy. They all have somebody they can talk to, which is also important with this setup. But I actually have a rolly chair that I keep on this side of the classroom. So any student on the left side over here, if they have a question, I grab my rolly chair, roll it up, sit right down next to them. We're working. It's like we're working together at that point, and I'm not really kind of hovering over them. And also because sometimes when you're debugging code, it takes 5 or 10 minutes. It's going to hurt your back after a little while bending over like that. Be able to sit next to all of them. In the middle row here, I have access to the left and the right side. This middle row over here, I have access to the left and the right. I have my side row over here with another rolling chair where I can access all these people and I can sit next to these two. It gives all my students a partner to work with and a partner to bounce ideas off of, but it also gives me the ability to sit next to every single one of my students. And even more than that, let's say you don't have the ability to set up this kind of classroom. You don't have this ability to really kind of sit next to every single student. Something else that's really helpful is just getting on their level. Again, I'm a bit younger, so I can squat down and I can, but even if I don't have a rolling chair, if I have 28 kids in that classroom, if I got a kid right here who's asking a question, that whole row is filled with kids, I'll lean back, I'll squat down a little bit. I want to get on their level. Getting on their level and really working with them kind of gives them the sense that, hey, they're here to help me and collaborate with me. They're not going to stand over my shoulder and say, no, you did this, and wrong. Like you're helping build that rapport a little bit more by really bringing yourself down to their level and kind of working with them. Super important in a CS class because these questions, it's not a simple math question that they have. It's usually, hey, my code's broken. Can you look at this 50 lines of code and tell me what's wrong with it? And so it makes a big difference. Now, this is a fun one. This is a fun conversation. Academic dishonesty. It's getting worse for everybody. I know it is. Biggest thing I use to combat academic dishonesty is check-ins. Check-ins, because when you check in every week or every other week or every unit, when you check in with a student, you're seeing what they're doing at that point in time. You're seeing what their current level of understanding is. You see what they know. You understand what they know. You understand what concepts they understand and what concepts they don't understand. You see their programming fingerprints. Every person has a programming fingerprint, how they do certain things, how they structure certain things. You get an idea for what they do. Even if you have 150 students, checking in with all of them, you get a general idea. So that way, when you get that project, you know that we've been working on for 4 days in class and you didn't see them work on it at all. And you get that project the day it's due and it's all of this code. You're like, I didn't know they could do that. Well, you didn't know they could do that because you've been checking in with them. That gives you a bit of an idea of where to start the investigation, if to start an investigation, because then it's becoming more and more of a problem with all kinds of students. So when I see something like that, the first thing I do if it's a CodeHS assignment is actually go to time tracking in CodeHS. And time tracking is just, don't know if it's a pro tool, so Lori will have to help me out here, but time tracking is, it's this little, you just go to progress, time tracking, and what it does is it tells you how long people have spent. So I could go over that, I could time track to see who actually did my little activity earlier and see who did what. So I won't do that, but it kind of gives you an idea, right? Like, okay, everybody normally spent 20 minutes on this assignment. They finished it in 30 seconds. That's a little suspicious. Go back in, look at the history of it. You can kind of get started from there. Now, time tracking is kind of useful. Like I said, I don't check it every time I quit, but when if something comes up, whenever, like I know for a fact, I've been checking with students the day before something's due. I do a check-in. This kid's got 10 CodeHS assignments that he hasn't done yet, and they're due tomorrow. And then magically all of them are done. And you know for a fact most of the class asks a question about this particular one assignment. And I kind of go back and I double check, I look at time tracking, I see what's going on there. I don't let them know they'll have access to time tracking. Then they'll just sit on the assignment and then just like sit there for 5-10 minutes and then copy and paste the code. And so it makes it harder for you to see. The other thing is ChatGPT. You can't really get around it. And this year, I'm actually going to be experimenting with a lot of ways on incorporating it into the classroom. But the very first thing I did, because I love AI, I love all that stuff. I've been following OpenAI for years. We used Dolly, right? When I first got access to Dolly at the beginning or at the end of the summer in my class, we did all that stuff. And so as soon as ChatGPT started to surface, I was like, okay, this thing can build programs. The very first thing I did, I spent an entire day just playing with it, learning it, seeing what it could create. I took almost all of my projects and I created different prompts to get it to try and build projects as my students would build them. What you notice when you start to like kind of play around with it and like plug some of your work in there is you'll notice that it uses programming best practices. When you're teaching students programming initially, you usually don't teach them best practices. You teach them the stuff that's easy and that makes sense. And so understanding kind of like how that works and how it structures a program. If you're teaching Python, you get a project and it has a method called main underscore, right? They probably didn't write that because we don't teach that, but that's pretty much an industry standard, right? Is like how you write a Python program that's coming from somewhere else. But the thing is though, if you're confident enough, and your school lets you, don't ban ChatGPT. Teach proper uses. I mean, something that we've probably all used at some point or another, Stack Overflow. We have this little Stack Overflow symbol right here. Super useful. ChatGPT, I use it as like a Stack Overflow that can answer your questions, right? That you don't have to go find something that's kind of like what you're trying to do and then kind of make it work. Ask your specific question, give an example, try something from that example, and kind of use it to our advantage. I think CodeHS has something in the works, or has something that's coming out that's going to be working with AI and using AI in the classroom. I think that's going to be out next year. Is that something you know about, Lori?
Sorry, I lost my mouse for a second.
Oh, okay.
So the AI things that we're developing, is that what you were mentioning?
Yeah, I thought I'd gotten like an email or something about CodeHS building something like that.
Yes. So we are in the process of developing some AI and adding that into the platform. We're going to have some AI grading features. We actually have many of those in beta right now. If anybody's interested in checking those out, drop me an email, and I'd be more than happy to drop you into the beta group for that. You can check those out now.
And just my whole opinion on AI is take it into the classroom, learn how it works, learn how to best utilize it. It's not going away. These kids are going to have it forever. So then it's only going to get better. So just teach them how to use it properly. In my own college level computer science classes, my graduate classes that I've been taking, I use ChatGPT all the time for assistance. So the thing is, we all programmers are great at Googling. We're really good at Googling, right? Like you learn how to Google well because you get stuck on something, you need documentation for something. AI's helped me out because the Google, the spending 5 minutes looking for the exact thing I need, the exact form of documentation, the exact example, I can plug that exact question, right? And I can get an example. I can see how I'm supposed to build something along those lines, then I can go and implement it. It's like I said, it's like a Stack Overflow that responds immediately, right? And in extreme detail. And so use it that way. And teach your students how to use it that way, and not to just, oh, here's the prompt for my performance task, or here's the prompt for this project, build me a program, copy and paste it over. Because they don't learn anything that way. But we can learn and we can use AI to kind of use it. It's essentially like a more specific form of documentation. Is how I utilize it. All right, so those are some of my best practices that I use in the classroom, usually on a day-to-day basis. Any questions so far before we move into our final section?
I have a quick question.
Yeah.
So a lot of what you mentioned is incorporating like self-paced, exercises in your class, and kind of doing a mini lecture at the beginning and then letting the students go and continue with that. So this is only my first year teaching computer science this past year, so I'm still trying to figure things out. But my district is really big on using Kagan structures like collaborative learning, doing turn-in talks, that type of thing. And I was wondering if you have any experience with implementing those types of things, and if you do, how you go about doing it. Because right now, the biggest thing that I've found success with, to make it so that I'm not getting harsh feedback with every walkthrough that I get, is that I kind of keep the class on the same pace with a particular exercise, and then I throw in discussion questions. But I find that like either I'm hurting the students that want to keep going, or the students that need more time. Like I just have to move them forward, and I don't really know, what they know. So that was pretty like long-winded, but I don't know if you have any experience.
Oh no, I know exactly what you're talking about, and I think have you ever done pair programming before? The very next slide is going to be pair programming, but especially for administrators, if you set a pair programming project up correctly, and I'll talk about how I set it up, it makes their mind explode, because you get this discourse that you don't get anywhere else. You get this technical talk between the students, this discussion. I usually do about 2 or 3 pair programming projects a year. As for like the day-to-day, what I really do is it's really based on my seating charts. So what I take a lot of time to really kind of focus in that, especially after the first few weeks of school, to see where my strong students are, where my weaker students are. And I don't always do strong with weak, because that can kind of bring you down sometimes. But what I'll do is I'll do maybe like a stronger student with like more of a medium level student, but put another strong student in the group nearby. That way, as they're working through things, because the thing as a CS teacher, especially in those upper level classes, like if you teach CSA or you teach a higher level class where you're going to spend most of your time with 2 or 3 students in that class, but you've got 20 kids. Well, what ends up happening is I allow students to really get up, move around the class, and help each other out. So if I'm stuck with one student for 15 minutes and I've got like 3 other kids, I know that I'll put them near a buddy, or I'll put them with somebody who's strong, who I know is going to, and they'll start to collaborate, they'll start to help each other out a little bit. And also really building that culture in your classroom makes a huge difference as well. To getting them to interact with one another, getting them to kind of bounce ideas off one another, getting them to help each other out. Because I'm only one person, and if each question takes 10 minutes, I get 4 questions in. I have 10 kids that have questions. So it's really that's how I see it. And if you have a planned observation, I'll tell you, every single planned observation, when an administrator comes in and they've scheduled an observation, I always do it on a day we're doing pair programming, just because the conversations you see in pair programming. In fact, let's go right there. All right.
I was gonna say that
Okay.
I do the same thing you do, is I put higher level, or medium level with the ones struggling and have them help, because you only have, like you said, you only have so much time, on that. And I also wanted to say something on the check questions. You were saying the checkpoint questions. I use those to intermingle with my students, and we do those questions together. And I ask higher level questions from those questions. So I'm like, like this, what do you think what do you think the answer is to this? And then some of the students will say this, this, and this. And I'll say, well, why do you think it is this? What makes you think this is the correct answer? And so then they'll get to talking amongst themselves. And so it gets a big group discussion going. So it's kind of cool. And that's why I get some of the students that are not very talkative or anything, so it's kind of fun. We have a ball doing that, but I've had really good luck with that, with taking those check questions and using that as because our school is really big into higher level questions, so I've used it for that. So I just thought I'd say
that's a wonderful use for those check for understanding questions. What I started doing is my warm-up became, because I teach AP Computer Science A and AP Computer Science Principles, first 2 minutes class every day, CodeHS question of the day. Greatest creation CodeHS made this year is a question of the day. It's amazing. You get in there, you talk about it, you see an AP level question, they do it. They get streaks for getting them right, so they're incentivized to actually answer it correctly. And we have those discussions. Now I don't use the check for understandings those ways, especially in a Python class, because I tend to find those like a little bit of a lower level. But if your class is at that level, that's perfect. Yeah. Using those discussions, using those as like the basis for discussions. Now, most people have probably heard of pair programming. It's everywhere, it's all over the place. But if you set it up correctly, it can lead to probably one of the coolest classrooms you'll have, right? And when I first mentioned pair programming, my first level students, they've never done a pair programming project before. They're like, oh, we're going to be doing it's a partner project. It's not a partner project. It is not a partner project. Pair programming you're working with a partner, but it's not as like, oh, we're both just doing this project. No. I have specific rules for my pair programming project. We have 2 roles, right? You will either be a driver or you will be a navigator. Now, those roles can swap at any time according to my discretion. So if I see something and I want to swap those roles, I swap those roles. But essentially the driver, they're working off of either one computer, and I actually have it set up in my classroom where they can both they can add themselves as collaborators on an assignment, and then I literally I unplug and take the keyboard away from the navigator. They don't get a keyboard. I take it away for the class, or for the project. And so you have one kid that can type, and they can only type exactly what's dictated by the navigator. So it's not just, oh, mindlessly typing. The navigator can't type. They can only dictate to the driver. Now, when I first say that, students like, okay, I want to be the driver. I don't have to do anything. I can just sit there and mindlessly type. No. I have another rule. My other rule is that at any point in time, Mr. Kramlich can come up to your group and I can isolate one of them. I can say, hey, so just you explain this section of code to me. If they cannot explain that section of code to me, delete. I get rid of it, right? And that kind of forces them into that conversation, because you can't just mind if I have the threat of Mr. Kramlich coming around and deleting your code, right, is there, right? It's okay. Before you type this, let's talk about how it works. Let's make sure we both understand this before it gets put down, because he's going to come delete like a day's worth of progress. And I will. I've done it many, many times before. Because what you'll end up doing is you'll get one student who's just kind of like dictating all of it, and they're just finding this, like, and they have no idea what's going on. Now, in this sort of situation, and it depends on the student. There are some students that, some strong students that will really help out those weaker students. There's also some really strong students who won't care about the weaker student and won't help them out. Sometimes putting a student who's maybe just a step above. I've even done it a couple of times where I put 2 weak students together in a pair programming project, and because they're collaborating, they actually did research, they referenced documentation, and they learned way more than if I put them with a stronger student. But my general rule of thumb, especially first part of the year when I don't know how, like, where all the students fall, a stronger student tends to work a little bit better as a navigator, and then having a driver. Now, I don't leave the roles the same. I always tell them at the start of the project, I will swap these roles. Like halfway through the project, I'll swap the roles. And then usually it's once most of the project is done and they're just doing the finalized things, I'll swap the roles. But this kind of masks that a little bit, because what ends up happening is like, oh, we got a new seating chart. Oh, we're doing a pair programming project. Oh, I'm the driver, so Mr. Kramlich thinks I'm the stupid one. And so what you do is you kind of obfuscate that, right, by like going through and kind of like saying, oh, okay, I'm gonna flip flop these roles, or like at any point in time I can come and swap the role around. So if I see the driver just taking off without the navigator, I say, oh, swap, right, and they'll swap roles. And I have to say that way. And what you'll start to see is you'll start to see what I call like the mind melding, where they're becoming one program, right? Like the discussions they have are phenomenal. I've never had better discussions for my students when they're working on a pair programming project. They talk to each other. They have to make sure they both understand. The discourse is awesome, and administrators love it. So if you ever have a planned observation, get a good pair programming project, probably something that's based off of data. Build your seating chart based off of summative data if that's one of your standards, right? Apply it to a pair programming project. Or like, so when they ask for your documentation, oh, well, this person sat next to this person had this role because they were slightly stronger on this assessment. And so I put these two together. They're going to have this discourse. They love it. It works super well. Now, walkthroughs can't really help you there. You just gotta be on your toes at all times. But planned observations, pair programming all the way. And the other thing, which I don't know if I have anybody here who's in the CSA prep that I did a couple of weeks ago. There's another type of assignment that I use once a semester, and it's called a digital breakout project. Now, we're not going to have time for the activity and actually doing it. Now, if you want to get really fancy, my last planned observation, I took a digital breakout and I made it a pair programming digital breakout where they built their own. It was a whole very meta, but it was awesome, and there was a lot of really cool stuff that they did there. Now, all a digital breakout is, it's what I think of as like a coding escape room or a digital escape room. It's not as much fun as an actual escape room. If you've ever done an escape room, the whole goal is to escape the room, right? You solve the puzzles and you escape the room. It's similar, except you're locked into a locked Google form. And so the goal is to submit the Google form, but you can only submit the Google form if all of the answers in the form are correct. So let's take a look at this. So I have an example that I use with my students for strings. Now, this is it's pretty straightforward, right? There's a Google site, and so we'll take a look at this Google site. And on this Google site, there is a Google form, okay? And there's also Google Sheets. Now, this Google form just asks, I did this as a pair programming project, so they actually did this 2 people together on one computer. It has a whole bunch of questions, right? Number of words, 2021st word, most used word, always. You might be saying, well, where's all this coming from? Well, what I've done is I have the Python file right here. It's HP, stands for Harry Potter, right? And it has in one gigantic string the entire first chapter of Harry Potter. Now, the whole why all of this text? Well, the digital breakout is usually an assignment I use to kind of teach data structures and for them to kind of show what they know and analyzing data. And so I give them this starter code, and what they do is they can build these functions that analyze the chapter one string, right? So they're essentially going through, and it's such a large piece of data. It's that I don't want to give them a paragraph, because a paragraph, oh, they can count the number of words physically, right? The longest word in just a paragraph, they can find that with their eyes. Good luck counting all those words. Good luck finding the longest word there by hand. So it kind of forces them by like taking the first chapter of a book. I do it with The Hobbit. I do it with Harry Potter, and making it into a string. You can do it this way. And essentially their goal, right, is as they go, they answer these questions. So if there's 20 words, go into 20, they can click off of it, and you can build in Google Forms. If you go to work with Google Forms, it's called validation, response validation. And all you do is you just set what the answer should be equal to this, and then you can give them like a little hint, like if they get it wrong. Once they're able to fill out the full form, right? So once they've filled out absolutely everything, they press submit. And the cool thing about this Google Sheets right here is attached to the Google form and submitting the Google form. So what ends up happening is we'll have a competition that spans a couple of days, and it'll be a race to see which team can finish and break out of the room first. And I'll have prizes and all those kinds of things. And so this is like a live timestamp of the leaderboard of who's finishing and what order they're finishing in. And I know we got to wrap here real quick, but just this is a more complex something I do end of first semester digital breakout. I made a really simple one for us to do. We don't have time for it though, but it's working with lists, and essentially we can just take a quick look at the actual data right here. And this one is using, you can tell like there's about syntax highlighting gave out about halfway through. This is 4,242 integers between 0 and 1. And why so many? Well, again, you don't want them to manually, you want to force them to build a program to analyze the data. And so that's essentially all it is. And then you have the directions of the Google site where it's linked to the locked form, and that ends up going up. And these are two examples you guys have access to. I double checked it all. Last time they weren't able to see some of the Google Forms and stuff, but feel free to take these, use these, expand on them, build your own questions. And what I actually did, my last planned observation, was a pair programming project, because they'd already done 2 digital breakouts before. They actually built their own digital breakout, and they had to essentially pick their own, like based on 4 topics, right? They had to pick which topic they wanted to do a digital breakout on. And then they had to build the digital breakout itself, build the questions, build the answer key. And then the last 2 days of the project, they actually got to share their digital breakouts and have another team try to break out of their digital breakouts. And like I said, you do stuff like that. You layer all those things together with discourse. You get the the data from summative assessments, and the administrator will read it up. It's kind of stuff you really want to plan for those kinds of things. Last thing I want to mention, and then we'll kind of go ahead and wrap it up. CodeHS this year has a new project catalog. I love it. I've been using it in my advanced Python class. There's some I've lost everything. Okay, this is fine. So there is a project catalog on the left side over here. It's got all kinds of projects in all kinds of languages. There's Python projects. Some of the ones that I enjoy most, this Mancala game. If you're a teacher, if you're one of those teachers who are teaching just Python, no CS, no CSP, this is the Mancala project is a great capstone end of year, or end of at least, like if you're not covering any more Python, that's a good one to do at the very end. I do it with my advanced Python students right before we start object-oriented Python. That's my optional 4th year that they take. They do that at the beginning of the year because they've already had a year of Python. Really great. Mastermind's really good. Right after lists. Game of Pig is pretty good, like a unit before that. And like I said, there's tons and tons, and they're already pre-built. You can take them, change them around, turn them into tier projects, whatever you want with them. And like I said, my favorite is the Mancala game. I love that one. I even actually have kids add color to the man color game at the end, kind of like what we talked about with cool color module. That's it. I'm sorry, Lori, I'm 5 minutes over.
That's okay. And honestly, I just noticed that you were over it all. I was very into what you were talking about. People are asking questions. This has been an amazing, amazing workshop. I've had a blast, and I think everybody is really enjoying all of this.
I was gonna say I loved it. I didn't notice we went on over until he said something because I was enjoying it. So
I wish we could have all done the
thank you.
digital breakout. The digital, it's fun. It's like I said, if you've ever done an escape room before, it's kind of like that, but just a programming escape room. It's so much fun. If you have questions on that, you can always reach out to me. I do them all the time. Or if you want my super meta project where they're doing pair programming to build their own digital breakouts based off of all that stuff. It's the project I usually use for like big observations that I can plan. If you want that kind of stuff, you can always reach out to me. And I'll get that to you.
So I think a good idea.
I would love it.
I think a good idea. Oh no, we're just talking on top of each other. I love it. I think a great idea for an upcoming workshop, Rob, might be just focusing on that. So
yeah, we never actually get to dive into one of those digital things.
I think yeah, I think we need to chat about that. So all right. So everybody, thank you so much. This has been amazing. I have just been so excited to be a part of this. I feel like I've learned a ton. And I also just want to go find kids now and do some of these activities. So I think the closest school district to me is going to get a visit this year. So this has been amazing. Couple of things just to wrap up. We do have a brand new CodeHS PD membership rolling out very, very soon, actually in the next couple of weeks. I think first week in July, probably July 1st. So definitely take a look at it. You can browse to codehs.com/PD/membership. That is also on the link stock, so you can grab the link there. This is going to be a really cool option to give you even access to even more PD options. With CodeHS, we have a ton of mini PD courses, and I know some of you have been taking advantage of those, and I'm very excited to see that. And the PD membership will let you have unlimited access to all of those, other workshops, and all kinds of things. Let's go to that next slide. I think we're almost there. All right, so other resources. If you are not a CodeHS certified educator, please, please, please take a look at that, apply, even if you feel like, oh, I'm not ready to be. Yeah, you are. Apply to be a certified educator. We'd love to have you in that group as well. We have a ton more workshops coming up. So definitely head back out to codehs.com/freepd to take a look at any of those and register for any and all. I'm going to drop that into chat really quick. This week we have more coming up with even more after that. So tomorrow we have another workshop, another Python workshop. This time it's going to be with Ken Pendleton. He's going to be doing some advanced applications for teaching Python 3. And his are going to be a totally custom kind of workshop. He will be doing, I believe it's his coin flip program that he uses with his kids, all done in the CodeHS sandbox. So you are not going to want to miss that. Definitely head out and sign up for Ken's if you have not already. And on Friday, we will have Siri Lamb with us, and she's going to be talking about Intro to AI and data science. And so I'm very, very excited about both of these workshops. All of these are Python this week. So definitely come on back, see more, spend more time with us. And if you can attend, at least register to make sure you get on that list to get the resources. So yeah, head out to codehs.com/freepd to do that. And I think on the next slide, we just have our workshop survey. Yes, look at that. So take a moment, please, to fill out our workshop survey, codehs.com/workshop survey. I think I put it in chat somewhere and it might have disappeared. Oh, there it is. I'm going to go ahead and drop it in again. But yeah, take a moment, let us know how we did, and let us know what else you'd like to see. I'm definitely taking note that digital breakout is going to be high on the list. So a little note for us, Rob. But yeah, let us know how we did. We love to hear your feedback. And I think that is it. So thank you all for hanging with us. I know we went a little bit over, If you weren't able to stay, you'll be watching this on your recording. So I'm glad we got to get all this really good information in, and I am just pumped now after this workshop. After a good workshop, I still can't help myself. I'm just excited and I want to go try some things. So Rob, thank you. Thank you. Thank you. I was excited for this workshop and you absolutely exceeded my expectations. So this was amazing. So thank you very, very much for being here and sharing all of your amazing strategies with all of us. It's been amazing. And thank you to the whole CodeHS team who has been out there helping with questions and links and everything else. And thank you to all of you for coming. This has been an amazing time to reconnect with you. I've known so many of you from so many other workshops and events and just emails. And it is just, I love getting together in these workshops because it does feel like I get to reconnect as well. Couple quick things. If you did send me a note about joining the AI beta group, I have added you if you did that in chat. If you sent me an email, I'll go through my emails after this and get you added. And thank you all. Thank you all.
Would you add me?
I will
Sorry.
add you, Carla. Yes.
Okay.
All right. I will add Carla. I just wrote you down. Thank you all for joining us again. We absolutely appreciate all you do for your kids, all you do for everybody. Thank you so very, very much. And please, please, please make sure you're taking time for yourself this summer. Relax, rejuvenate. And we do hope, though, that you do come back for another CodeHS workshop because we want to hang out again. So we'll make it fun. So it will be a relaxing, fun learning experience for you. But thank you for all you do. And we look forward to seeing you soon. Thanks, everybody.